All right. Well, thanks to everyone for coming. And as I had mentioned, I was hoping we could use this time for questions. Right. So we've talked about a lot of things over the last several weeks, and I thought we might take some time rather than to go forward and pile more ideas onto the plate. um, to see if folks want any clarification or have any questions that they wanted to go a little deeper on.
So I would like to mention what I was thinking about, what you said about model operations.
Yes.
And so can we see it as some kind of compression? Because if we remember every step of execution, we will have all the possible rewrites. And with model operators, we can express some kind of range of rewrites, and we don't need to store all of the steps in execution. Is this make sense?
Yes. So if you're talking about possibly using the behavioral types to um, to verify blocks as a as an approach as opposed to doing a replay.
Yeah.
If that's the direction of your thinking, it's something that I've been thinking about, but it's not clear to me that well, if we can get the if the proof rules are sufficiently constrained so that we're not doing symbolic execution, so that we're not effectively doing a replay just in a different form, then there is this possibility that we can use that we can a block when it's published is published along with a formula, and so then you can you just check that the block or the tuple space, either one of those, satisfies the formula. So that's I mean, if I'm kind of jumping to the application that you might be thinking about, but I don't know if that's what you're
Yeah.
actually thinking about.
Yeah. I'm thinking also in more general terms.
Okay.
For any execution, we can apply this model operations and say this formula is saying exactly what all of the steps are. Although we don't need to store all of the steps and show that we have it. So in that sense, I'm thinking like is compression.
So it's, you have to be a little bit careful, right? Because the modal formulae, as we've expressed them, are one step. Right. So.
Oh, I see.
We can generalize to multi-step. But if you do that right in the case of branching, it may be that if you go down a particular branch, there's an action that gets eliminated. Right. So you might be saying, I want to do this followed by that. And you can get stuck on particular branches. So you have to be careful about those sorts of things.
So when you talk about model operations, you're thinking about one step, right?
Yes. Again, you can generalize them to multi-step, but you have to realize that comes with a price.
I see.
I mean, Yeah, yeah. So if you look at the modal formulae that Milner introduces in the polyadic pi calculus tutorial, those are clearly one step. And if you look at the base semantics in Kyros's model, in Kyros's spatial behavioral observations paper, that's also one step. Both of them can be extended to eventually kinds of operators, but it means, you know, that there's a lot more symbolic execution underneath the covers, right? Because now you have to
I see.
check all branches and
So composition of model operations are, that doesn't mean that this is multi-step, or is it directly related?
no, it is multi-step. So if you're, hang on, let me bring up a, um, oops.
Your last explanation about what is coming from where is you know, it's very helpful.
Cool. So let me do the screen share. Just so make sure we're talking about the same thing. So can you see where my
Yes.
cursor is? Okay, okay. So if I have something like, you know, um, alpha, and then let's say alpha sub 1, and then alpha sub 2, right? And then dot, 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 alpha sub n, and then phi. So there's my formula. So if P satisfies this, right, or another way of writing that is that P has this as a type, right? P inhabits that type. Then what that means is that there's one branch of execution along which P goes by some action in alpha, say call it A, alpha, so call it A1. And remember, these alphas are namespaces, right? Goes by A1 to some, let's call this P1, okay? But remember, there might be multiple branches, like there might be lots of uh, actions that P does, but there's at least one that lives inside alpha. And then it's got to be the case that, so that will peel off the first of these, right? And then so we would have to have that P1 satisfies this one, right? And so then, and let me change the notation. So this goes to P2, all right? So we can keep track of that, right? And so what that means, of course, is that P2, there's at least some A2 taking P2 to P3, right? And along with, it might be easier if I did it this way, comma, right? And then comma P3 satisfies. So let me do this. Oh, we have it just above, so I don't have to do that. And then P3 satisfies. Right, and then all the way out to dot 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 um, PN satisfies.
So each alpha is one step,
One step.
and we are combining multiple steps.
Yeah, by combining the modal operators that way.
I see.
Yeah. Yeah.
Yeah, this helps. Thanks.
Sure. Sure.
Yeah. Yeah.
Any other questions from anyone about any of the things that we've talked about over the last several weeks? We've talked about a lot of stuff. And so if there's, any any the material that people want to take a look at and cover again, now would be a good time.
Greg, I don't have a question regarding what you've covered over the past few weeks, but I just wanted to bring up a discussion we've been having in the tech governance sessions on Thursday,
Okay.
where we're working on we're going through the RCHIP process, and we've created some RCHIPs. Most recently with our groups is RCHIP 8, 9, 10, and 11. And the discussion or the debate, well, here, let me give you an example of what RCHIP 9 is. It's improved string function and exposing Scala regular expressions. RCHIP 10 is regarding bitwise operators to calculate things like log2. And RCHIP 11 is need event processing framework. So the discussion is around whether our node should have this additional functionality, or what we've decided is our node should be just very basic, and that there should be these additional features and functionality should exist outside of our node, almost as if they should be extensions. And that way our node can be do what it does best, but then users and validators can go to specific shards, perhaps, where they can access specific features to get additional functionality. So I think there's a few of us on the call who were in that discussion who could probably explain it maybe a little bit better than that. But I think that's kind of the basis of the discussion. So we wanted to get, or at least I would like to get, sort of your input on that topic, because it's from a tech governance standpoint, it's pretty foundational. So having your insight would be helpful.
Sure. So in general, I think it's a good idea to have different shards expose different compute capability. That said, I think there's a critical mass for row-line functionality before we call it actually a general purpose programming language. So all the logical operations, I think, is reasonable to have inside, an authorized or sort of co-op blessed Rolang. So I think that those are some things that I think are absolutely reasonable to have inside Rolang. With respect to event processing, the whole point of the process calculi is that that's what they're good at. They're really good at event processing. So I'll screen share again. You can think of um, a situation like this where um, I I have some event E, which is represented by uh, well, let me do it this way. Some event E is actually the output of some value on a channel. So some value being present is an event E. And then what we do when we recognize that event is expressed as a for comprehension. So for some pattern on the event, on the value, right? So this is a, when the value looks like a certain thing, um, um, right? So we've gotten that value on X, and when it passes a certain criteria, then we do some code, right? So this is the, let's call it process event. And that would be whatever the binding stuff is in the pattern. So just for grins, I'll make the binding variables in the pattern explicit. So let's call them W1 through WN. Okay, so those are the variables that are bound inside this pattern. And so that means that V matches this pattern. So V can be some complex data structure, right? It could be some tree or some graph or whatever it is. And that data structure pattern matches with this pattern. And as a result of the pattern match, it's binding these variables, right? And so then we take those values that we've gotten out of that data structure and we can process them. So this is effectively the basis for an event processing system and an event processing interpretation for Rolling. It's designed specifically to build complex event processing. Does that make sense?
Yeah, yes, I understand what you went over. Now, I guess I had to go back to my tech governance notes to kind of refresh myself on the nature of the conversation as far as what our chips would actually be extensions of our node. It almost sounds as if when you're talking about this process event, if that's an inherent capability of Rolang, and it doesn't take any additional resources, it sounds to me as if that should be an inherent or just a part of our node itself, as opposed to some type of external extension.
Yeah, I guess what I was saying was Roland was designed to do complex event processing. That's
right.
one
Okay.
of it. So for example, let's say that you want to do alerts when a particular sensor reaches a critical range of values, right?
Mm-hmm.
So so X is the sensor, V is the values, and the alert handler is the for comprehension. So I mean, it's designed specifically for this.
Right. Okay. So yeah, I guess I need to kind of separate what, the Rolang as a database that does computation as opposed to separate from our node itself. So Rolang has this event processing functionality, whether it's on our node or as an extension on a shard outside or an additional validator. So perhaps.
Yeah, I'm just saying we don't have to add any additional framework. It's already there.
Okay.
Right. So I mean, the nice thing is that if you think about complex event processing applications, they're really next-gen database applications. So the insight of Rolang is to view those two things as the same thing.
Okay.
Maybe I can explain the discussion we had around this subject. So the issue was that right now, if we want to read something from the blockchain, basically we do explore deploys and we get a value back. But something that is not possible currently is to have a push requests from Arnode when some specific event occurs. And this is the feature where we discussed about having this as an extension capability from Arnode, but not some built-in mechanism inside Arnode that could notify third-party applications.
So, so in general, you can do this in a lot of different ways, right? I mean, it's very similar to what people do with HTTP currently when they do these long-running things. So you register a you make a dummy request so that you always have a request hanging out, and so then you can always push a response to that request, right? That makes sense.
Yeah. I think it's kind of the old way, but the top would be WebSocket support. But the issue was just if this feature should just natively supported by Arnode. For example, when some value is sent to a channel, some push events in WebSocket are issued by Arnode to all the listeners.
Sure. Right, but again, you can write that down in Rolang, right? So the idea of a WebSocket is really just I've got a bunch of listeners, right? So that means that the listeners have to be sitting there, and then they're notified, and so that's very straightforward, right? So a bunch of listeners are going to be of the form for pattern 1 from W11 through W1N. Oops, yeah, that's right. And this is the listener specific registration, right? So listener of X, right? So this listener has registered that they're interested in values on X, and there's a specific ID associated with that listener. So I'm representing that as listener of X, right? And then it's process event, on N. And then we have just a big parallel composition of these guys.
Yeah, okay.
Yeah, so we can, so Rolang is already set up for precisely that. Now, the one thing that our node needs to do, and I've long thought that this was an important part of our node, is to dog food events about the node and put them back into the tuple space. So, for example, a value was written to this channel in the tuple space. That could be a, when you want to inspect the node or watch the node, you can create another communication event about that. Now you have to be careful about regressive loops, right? So if you ask for those kinds of events to also be watched, then you'll recurse, right? So you have to be careful about that. But in general, you can make our node record events in the tuple space about our node. And that becomes very useful for our node monitoring, our node health, all of that stuff.
And basically, we are doing this for rep transfer.
Yeah.
Right. We are we have a complete event log with all the intermediate values, and this can be also as input for these events. So, for example, with Trace API, if you replay the whole block, you have all of the events that happened inside of execution of this block. So you can read this and you can publish this or via WebSocket or any other protocol. So even now we can do this.
Yeah, yeah.
So we should do this with the analyzing the event log of the execution.
Yeah, but it's difficult to analyze just event log because you have just the hashes of the final state. But if you have if you execute trace, you will get all of the events.
Yeah, but the idea is to kind of shred that information back into a specific namespace inside our space. So so it's a separate namespace, right? That is where those names are used to publish information about our space in our space. And the reason you keep it separate is to firewall it off so you don't get these infinite recursion. Like you're not in that namespace, you're not allowed to do the operations that would publish events back to that namespace.
Yeah, nice.
Yeah. So that's
so this means that we can in rolling we can filter the execution of the rolling and publish this in another namespace in rolling.
correct. Exactly. Right? Yeah.
Nice.
So it becomes reflective, right? So you can now use Rolang to talk about our node, which is what should happen. I mean, it's yeah.
So there should be part of our space which is not on the blockchain, but for just a node itself.
It can still be on the blockchain. It's just that you can't do a meta recursion. So you can do a reflection on some normal contract, and that will then generate events in some other namespace. But you can't do reflection on that namespace because then that would cause a recursion, an infinite recursion. So the node would grow infinitely because it's always talking to itself about itself. Does that make sense?
So we are like refining event log in one namespace and producing some smaller subset in another namespace.
Yeah.
We can do this multiple times as we wish.
As long as it shrinks every time.
Yeah.
And what will be the logic for publishing? How do we technically tie these RSpace events with the outside world? So in general, there should be some listener on the name, which when some code is executed, should fire up the outbound, for example, WebSocket or HTTP or something else.
So I would separate those two concerns, right? So the way I would do it is you don't engage this functionality in general. You only do it if someone. It's like turning on debugger, right? When the debugger is on, the execution is going to be much slower, right? Because the debugger is now watching all the values in the stack and all of that stuff, right? So this is the same idea, right? So when you mark a contract as in watcher mode or debug mode or whatever you want to call it, then whenever there's activity on a particular name mentioned by that contract, an event gets generated which posts in this other namespace, which is a function of the name, right? So there's some way to calculate for that name, the name where the information about the activity on that name will be published. And then because it's a function of the name, you can then write code which uses the function of that name to go and get at the events over there. Does that make sense?
Yes. So this means that the main way to get data out of the chain is to analyze the event log.
So, something like
or to produce some debug messages while you are executing your code, storing it in some rspace folder, rspace namespace, and get it out from there.
Right. And so then the next step is, I just wanted to make sure you understood that part. Then there's a separate part, which is registering listeners, right? So you can have listeners that are external to the node, that are interested in, things that happen at, on functions of names, right? So debug of X. Then you can write Roland code which listens on debug of X and then publishes to the set of listeners that have registered for that information.
Yeah, so this is where this was the part of the discussion as well on the tech governance. So basically there should be some support of Roland code to trigger outbound connections, because and this is because because I asked question if this is on a blockchain or not, this separate namespace, because if there is some Roland construct, it should be supported by all nodes, because they all should be able to replay. And that's why Tomislav was saying that we should be careful when we are introducing additional Roland functions. So basically each new Roland method is a breaking change, because everyone should update or they cannot replay the block.
Correct.
And this led us to some extension methodology, that there should be some extension that can be loaded into our node, which can read some information maybe directly from our space, maybe with some another ways attaching directly to some Scala interfaces.
So I think what I would do from the point of view of release management and forking and breaking changes and all of that, is to roll that kind of reflective node, using Roland to reason about node functions into Roland 1.1 release. Right. So it's not just that we extend the language, but we also extend the execution environment to give this additional capability. And people have been asking about this capability since the beginning of 2018. So application developers have asked us specifically for this.
Yes.
Yeah. So
I wonder, should this be just part of the read-only node, or from a deployment perspective?
No, this is a general purpose capability. It's not just read-only.
So I wonder, this will be part of Roland 1.1. What was it in your mind before, or you're going to?
Well, I was trying to articulate things a little bit finer grained, but it's reasonable in my mind to lump these together. We can say that, Roland 1.1 not only includes the language extensions. I think, how do I say this? My articulation of the features and functions associated with Roland 1.1 is first just to offer the syntactic sugar. And then the next step is to offer not only the syntactic sugar, but the corresponding optimizations that can be had in R space. Like once you have the syntactic sugar, then you have now you have enough information to know that there are certain there's certain interactions that don't have to be turned into COM events that can be streamlined, which would give massive execution improvement for Roland code. And so that basically turns into updates to the compiler / interpreter. And then you can go from, since you're going to do that, then it's reasonable to also extend the RSpace mechanism with this reflective machinery. So those would be like 3 stages of the Roland 1.1 release. Does that make sense?
Yes. What does it mean for execution to be streamlined, but not with the COM events? What's
So if you
technical?
look at the Rolang 1.1 specs, there are um, the syntax is able to identify names that are just being used for synchronization, that have no transactional interpretation in terms of the outside world. They're entirely about coordinating little bits of code. Right. And so today people are actually generating those names, and like, so in order to force a particular sequencing event or some other kind of handshake, they're generating those names by hand, which means that there's corresponding threads, and uh, um, and all of the execution that goes along with it. As soon as we know that the names and the COM events that are associated with those names are just for this handshake, then we can get rid of those threads. We can just turn it into straight line code. So there's no spinning up of threads. There's no, synchronization of the threads through our space, all of that. It just becomes straight line code.
What I'd like to do, I'm going to put in the chat. This is in the RChip repository. There's under the issues tab is where I'm putting all of the RChips. So RChips 1 through 7 it goes back a year or so with the original group that was working on the RChip. So I put those in there just for comprehensive sake. But starting with RChip 8 to 11 is what the group we have now is currently working on. So it's good we're having a discussion so everyone's kind of on the same page as far as what discussions are about. But what my thoughts is, and I have a general sense of the conversation that's going on here, but not to the degree that I would like. But perhaps based on what we've talked about in the past half hour or so, or 20 minutes, perhaps Greg or NetZipper or Tomislav or whoever could go in there into the issues tab for a look at the specific RChip and just add some comments on thoughts pertaining to this conversation, just so we can go back on Thursday and have some guidance as far as where we're going with this. So just to add clarity. So sure. I think it's certainly a good discussion, and I'm glad we're talking about this now because we're getting on the same page is a big part of it all. So
yeah,
good. Thank you.
Yeah, no, that's reasonable. Totally reasonable. All right, go ahead.
I just have a question related to that. Is it make sense to, for example, to introduce new methods in Rolang only one shard? For example, that we want to test something. For example, Arthur created extension to Rolang to call some Rust libraries for zero knowledge proof, and his presentation really convinced me that this is just another crypto functions, right?
Sure.
So does it make sense to that we have only these functions available only in one shard, and we can test it, and this can become RChip proposal, and we can say, yeah, this is very useful, and we want to push it into main release.
So I have long felt that it is reasonable to have shards offer specific compute that are not offered by other shards. So a really good example in my mind is SAT solvers. Like, it's not necessarily the case that some SAT solver package needs to be, a part of our node, supported by the co-op. but someone might, extend our node to include some fancy sat solver, and then, they've done the work to do all the cost accounting around calling the sat solver. And so if people want that particular capability, then they go to that particular shard or the shards that support that. Right. But it's not something that's in general released by the co-op or supported by the co-op. But there's enough of a trust infrastructure for people to be happy with, the risk of going to those particular shards with those modifications to the node. So it's a world where, where we have both, right? So people put forward certain extensions to Rolang, and the community agrees, okay, yes, that's general purpose enough that goes into what's supported by the co-op. And then at other times, the community goes, no, this is not general purpose enough, that's more specific. And then certain shards support those functionality.
I'm glad Thomas Shaw brought that up, because that was sort of the root of how our Thursday tech governance discussion started, was with the Arthur Grief's zero knowledge proofs, and with the byte to hex, or hex, I think it's byte to hex. So he's been doing a lot of work as far as with his project that he's working on. So I believe there's a pull request out there, or soon to be, and knowing what to do with that is, I guess, what we're kind of working through. So so that was that zero knowledge proof, range proofs, bullet proofs, all of those things. Is Arthur has a strong background on that. So I get a feeling that with Arthur's need, his current need that he has, and his motivation to kind of push that along, that may be kind of where we start in this effort of these extensions to this extension functionality, as we've been discussing.
And the other practical question is, while at a point now where we don't have sharding, how do we deal with these requests or proposals? Is there some other methodology before we have sharding in place?
Yeah, I mean, the way I would do it is just wait until we get sharding and then do backlogs. People can always fire up their own versions of nodes, right? And at least at this point, like, as long as the node speaks the protocol, then those nodes can join a particular shard.
So that would be an interim fix or interim solution for Arthur Grief, is him running his own known node to have that zero knowledge proof functionality.
Yeah, but that would mean that clients are kind of stuck to those nodes if they want those functions, and there would not be the ability to do replay if those functions are employed.
Okay. Well, maybe that's a piece we need to work through as well, is knowing what the ultimate solution is when we have sharding, and that the ideal situation for the zero knowledge proofs will be with the sharding, but having an acceptable interim solution for Arthur, because he's kind of like Raphael with it. Raphael is blazing a trail ahead with Dappy, and Arthur Grief is coming up pretty quick with what he's working on. So I want to create an environment where he feels that he's supported. We're paying attention to his needs that he has, and we're actively working towards at least an interim providing a solution that's going to work for him. What that is going to be exactly, I'm not sure. I'm getting a sense from the conversation of what it is, but I think there's this coordination that needs to go on, so that at least everyone's kind of aware of what's happening and what the needs are, and based on that, what the next appropriate steps would be. So once again, I'm glad we're kind of having these discussions as far as what the current needs are from these extensions and functionality, and how to get to something that Arthur's going to be happy is going to be the next point of discussion, or points of discussion ongoing in our tech governance.
Sounds good. Sounds good.
Yeah.
I mean, it may be that Arthur's, you know, offering, you know, the ZK functionality is, you know, everyone agrees that it's just, you know, it's just commonplace enough, or, you know, like it's general purpose enough that everybody wants it, and so then it just gets adopted as a node extension. But you know, but there has to be a sort of community process around that. I need to jump off before stand up, so I will. I'll leave it here. If you know, if people want to keep talking, we can leave the room going. But I'm going to stop the recording. Do people want to keep?